Oxidation numbers in polyatomic ions. That is ions that are made up of 2 or more atoms. So what is the oxidation number of nitrogen in NO3 minus? The good news is we already know the oxidation number of oxygen to be -2. So we first write that out to be -2. So let's write it here. Oxidation number of oxygen is -2. Now if we check NO3 minus, below the subscript of oxygen is 3. So that means there are 3 oxygen atoms in NO3. Meanwhile, one of them has an oxidation number of -2. So 3 will have 3 times -2. So basically that's that. The 3 that I've used to multiply the -2 means there are 3 oxygen atoms in NO3. Now we are looking for the oxidation number of nitrogen, the unknown. So we represent that with an alphabet that is X. So now we have 3 times -2 plus X. The next thing that will help us to find the oxidation number of nitrogen is to check the oxidation of the entire polyatomic ion. And the oxidation number of this entire ion, that is NO3, is for -1. The oxidation number of this ion is the charge on the ion. And the charge of this ion is -1. So that means 3 times -2 plus X is equal to -1. After we are done writing this equation, then finding the oxidation number of nitrogen becomes easy. 3 times -2 gives us -6. So -6 plus X will give us -1. Good. But we are interested in finding X. So what do? We just move the -6 to the other side of the equal to sign. Now I have X equal -1 plus 6. So -1 plus 6 gives us plus 5. So the oxidation state of nitrogen in NO3 minus is plus 5. Take note, it is important to show the positive sign. So do not write X equal 5, but rather X equal positive 5. So we are done with the first example. Now let's look at SO4 2 minus. What is the oxidation state of sulfur or S in this ion? First things first, we know the oxidation state of oxygen, -2. So let's write it down here, -2. Now check SO4 2 minus. How many oxygen atoms do we have in SO4 2 minus? Do you get that? We have 4 oxygens there. So we multiply the -2 by 4. Now we are looking for the oxidation state of sulfur, which is the unknown. So let's represent it with an alphabet. With our case, we are using X. So 4 times -2 plus X will be equal to something. That something is the oxidation state of the entire ion. And take note, the oxidation state of this entire ion is the charge of the ion. And the charge of this ion is -2. So 4 times -2 plus X is equal to -2. This equal -2, that -2 is the charge of the entire ion. Now 4 times -2 gives us -8 plus X equal -2. Did you catch that? Yes. So X will now be equal to, we'll move the -8 to the other side of the equal to sign to give us X equal -2 plus 8. That means X is plus 6. So you see, so that means the oxidation state of sulfur in this particular polyatomic ion is plus 6. So there is no wonder that when naming this polyatomic ion, we refer to it as tetraoxosulfate 6 ion. That is where the 6 is coming from. Tetra, because there are 4 oxygens. So tetraoxosulfate 6 ion. I think there's another example we should take, that is NH4 plus. There is no oxygen here, but we have hydrogen. What is the oxidation state of hydrogen in this ion? The oxidation state of hydrogen in this ion is +1, which we already know. If you have not watched our video on the oxidation state of hydrogen, it being +1 or -1, then watch that video so that you get to understand why this is +1. But let's write this out, +1. Now, how many hydrogens do we have in NH4 plus? How many hydrogens? We have 4, so let's multiply the 1 by 4. We are looking for the oxidation state of nitrogen in this one, so we represent nitrogen with an unknown alphabet, that is X, yes. And this X is equal to what? If you look at NH4 plus, the oxidation state of this entire ion is +1 because of the plus on top. So 4 times +1 plus X is equal to +1. Now let's move on to the next step. 4 times -1, +1 gives us +4 plus X equal +1. You see how I kept repeating the positives? Yes, because your final answer should either be positive or negative, and you should show the sign. So X is equal to +1 minus 4. Minus 4 because the +4 has been moved to the other side of the equal to sign. +1 minus 4 gives us -3. So the oxidation state of nitrogen in NH4 plus is -1. Hope you got that. Is there any other example? Oh, okay, there is this one, polyatomic ion. Good. Can you try this? So you pause the video. Pause the video and try it on your own. Okay, when you are done, let's go through and see if you got it right. We are looking for the oxidation state of sulfur in this particular ion, but we know the oxidation of oxygen. So oxygen is -2. So let's write it out. But how many oxygens do we have here? We have S2O3. That's from a -2. So there are 3 oxygens because of subscript 3. So let's multiply the -2 by 3. Now what are we looking for? We are looking for the oxidation state of sulfur, which is the unknown. So let's represent sulfur with X. But how many sulfur atoms do we have in this ion? We have S2. So there are 2 of them. So let's multiply the X by 2. So we have 2X. What is the charge of this entire ion? The charge is -2. That means 3 times -2 plus 2x is equal to -2. Basically, that is what it means. Now let's move on. 3 times -2 gives us -6 plus 2x equal -2. Good. Hope you got to this point, right? Now we are looking for 2x, but there is -2 attached to the 2x. So let's move the negative, so there is -6. So let's move the -6 to the other side of the equal to sign. So what do we have now? We have 2x equal -2 plus 6. So the -6 becomes positive at the other side of the equal to sign. So we have 2x equal -2 plus 6. So 2x gives us +4. -2 plus 6 is +4. But mind you, we are interested in finding the oxidation state of sulfur, which we represented using X. But now we have 2x. So what do? We divide the +4 by 2. So X is equal to +4 divided by 2. So X equal +2. Hope that is clear. If it is clear, give this video a thumbs up. So if so far you've enjoyed the way I've done this explanation, do well to give it a thumbs up and subscribe to the channel. This gives us an indication that you are interested in videos like this and motivates us to do more.